Yes, ma'am. Good morning, ma'am.
Good morning, ma'am.
Morning, ma'am. Good morning, ma'am.
Okay. So today, first of all, we have to decide who will be the fish today. So I selected the following numbers. Please let me know whether you are here. AG40, are you here? AG40? Not here. Rep, can you check? AG41? Can you please let me know whether 40 and 41 are here?
41 are here.
41 is here. 40 is not here. Okay, we'll see. Maybe they will join later. Then 50. AG 50.
The 50 also here.
Okay, 51. 51 here. Yes. Okay.
Yes,
Then 60. Is 60 available? AG 60?
no, miss.
No. Then 61. AG 61.
Available, madam.
Okay. Then 70. AG 70.
Available.
Okay. 71.
No, miss. No.
No? Yes. 71.
No, miss.
Okay. Then 80. 80. No?
No, no, miss.
81. 81.
No, miss.
Okay. So in that case, maybe I'll include, instead of 71, I'll include 73. 73 is available here. Okay. AG 73. Then who else? AG 49. Okay. Then AG 54. Then who else? AG 107. Okay. So you, those who I already told, have to answer the questions today. Okay. So what about the other students? If anyone want to ask any questions in the last class, or if you want any clarification, you can ask questions from the, you can just ask the question. I'll ask who has to answer. Yes, please. If you open up your mouth only, it will be an interesting session. Otherwise, I will be asking the same type of question. So if you ask, we can have different types of question. Please ask questions. Okay, so I'll ask question from AG41. Okay, AG41, can you, where are you? Can you on your video? 41?
Yes, ma'am.
41. Okay. So the question for you is, how can we improve bulk density of the cropping fields? Improve the bulk density. Yes? Improve bulk density. Very simple question. I am repeating the question. Yesterday also I asked the same question. Okay, 50 we cannot. Yes, 50. 50. Yes, how can we improve bulk density of soils?
Mass per unit of volume, including volume, total volume.
But bulk density, I am asking bulk density. And the question is how to improve bulk density.
Volume, total volume, volume of soil and volume of liquid and store volume.
I did not ask what is bulk density. I asked how to improve bulk density. Please listen the question and answer, please. How to improve? So to improve, whether we have to increase or decrease bulk density. If we want to improve, whether it is good to increase the bulk density or decrease the bulk density. AG 51, can you answer for that question? AG 51. Are you there? '51, please. Yes. So, how can you improve bulk density? And before that, if we want to improve bulk density, whether we have to reduce the bulk density or increase the bulk density. Yes. Then 60, AG 60. AG 60, please. Time is gold. Don't waste the time. AG 60. Yes, please. If we want to improve bulk density, whether we have to increase or decrease, which is better? 60. 60, can you on your camera? Can you on your camera, please? Ratish. Are you there or not? So how can we have student-centered learning with these kind of students? Okay, AG 70. AG 70. Are you there?
Yes, ma'am.
Okay, so tell me whether we have to increase the bulk density or decrease the bulk density if we want to improve. Which is better, higher bulk density or lower bulk density? Unmute yourself and talk. Unmute, please.
Yes, ma'am.
Yes.
Higher bulk density.
Is better? Then were you sleeping when I was teaching? Oh my God. Okay, 71. There's no 71. Okay, 73. 73.
Yes, ma'am.
Can you? Okay. You tell me whether increasing or decreasing the bulk density is better.
Increase in bulk density as a result of different land uses activities.
But please listen my question and answer. My question is, higher bulk density or lower bulk density is better for agriculture? High bulk density or low bulk density is better for agriculture?
Low bulk density.
Low bulk density is better. Okay, that everyone understand. Okay, so to reduce the bulk density, what we have to do? What management practices we have to do? Or how can we reduce the bulk density of a soil? AG 49? AG 49, are you there? You were there when I was...
Yes.
Yeah, you tell me, how can we reduce the bulk density?
Losing the soil and add some organic matter to
Yeah.
the soil.
Yeah, add any kind of organic matter or compost to the soil, then you can increase the volume and you can reduce the bulk density. So repeatedly I have been telling. I don't know about what others, why they are not, maybe they just join the class and they go outside. Huh? Okay, now AG 54. My question is, okay, so what is the importance of knowing weight of hectare furrow slice? Why we should know about hectare furrow slice? Yes. What is hectare furrow slice? Weight of hectare furrow slice? Can you tell?
10,000 meters.
I'm not asking 10,000 or what. What do you mean by weight of hectare? Simply tell me. What do you mean by weight of hectare furrow slice? What do you mean by that? The term itself giving you the answer. Weight of hectare furrow slice. Can you tell me now? What is hectare furrow slice? Weight of hectare furrow slice? Any other person, please? I cannot rely these fishes. Okay, G107. 107. Where is? Okay. Tell me.
It is used to calculate the nutrient.
Yeah. Okay. Okay. So how to calculate? What is the equation to calculate the weight of hectare furrow slice? What is the equation? Which density is used? Bulk density or particle density?
Particle.
Huh?
Particle.
Oh my God.
Bulk density.
Okay, so if you are interested only, I can teach. Otherwise, I will be frustrated. Okay, so because I prepare everything and spend a lot of time on preparing, and when I come and teach, if you are not interested and if you are telling something waste, so maybe I'll just come and talk and go. Okay, so if you are interested only, we can teach. So please. I already uploaded the everything and I already told you anyone can be asked questions. So if you are not prepared, then I will not help you. That is, if you are interested, you have to study, learn, and come. Okay, this is going to continue now. I have given you some questions yesterday. We'll see how many of you have done those questions. Okay, so now I'll share the screen and we'll do the calculation now. You have to do the calculation. I will not do the calculation. Okay. So weight of hectare farrow slice, that calculation we have already done. Then you should all know the derivation of these equations. So please do yourself. Otherwise, you will find it difficult. No, now, so what about this question? How many of you have find the answers? Yes, please, anyone can volunteer and tell. How many of you did these questions? No one? Okay, now do this question. Now do and tell me the answer, then only I can move. Can you see the slide?
Yes, ma'am.
Okay. So, how can you do this question? What is the question? Please, anyone, please read loud the question. That also I have to ask.
Two different methods of orchard soil management was practiced in adjacent plots having initial bulk density of 1.48 megagram per meter cube. After 1 year, plot A had bulk density 1.60, plot B is 1.1. Particle density is 2.65 megagram per meter cube. Calculate the change in pore space in plot B, whether A or B is a better management.
Okay. So, any other person, can you tell what you have to do? It is a very simple problem. So, initially a big land is there. So then for two different plot A and plot B, different management practices was done. And after 1 year, plot A had a bulk density of 1.6 and plot B had a bulk density of 1.1. Now your question is, calculate the change in pore space in plot B. So what you have to do? What you have to do now?
Calculate the initial and final.
Yeah, calculate the initial pore space and final pore space. So what is the equation? Another one, anyone tell? What is the equation to calculate porosity?
Porosity equal 1 minus bulk density by particle density.
Okay, so who calculated the initial bulk density? What is the answer?
40.16.
40.16. Is it okay, everyone? Others? Okay, maybe after 1 year. What is in B? What is the porosity?
58.4.
In B,
0.5850.
okay. What about okay? So what is the change now?
0.14.
Okay. So here I have calculated that. So the initial one, 1 minus 1.48 divided by 2.65, that is 0.4415 or 44.15. After 1 year, it is 58.19. So the question is, what is the change? So you have to subtract 44.15 from 58.15. So I think it is 40 naught or 30 naught. How much? Yes. Okay. So for B, so now the question is the second question. So now everyone understood that, no? So you have to calculate the initial initial porosity. So that is E equals 1 minus bulk density over particle density. So there should be actually a bracket here. Then, so initial bulk density is given, particle density is given. So if you solve this, this will come. After 1 year, for soil B, initial bulk density is 1.1. Sorry, after 1 year, bulk density is 1.1. And maybe yesterday I gave another bulk density values. Today I changed it. So if it is that is for B, it is the porosity is 58.49, and for A, it is 39.62. Okay. So now the next question is whether A or B is a better management. So which is a better management?
B.
B is better management.
Yeah, so maybe even without doing any calculation, you can tell B is a better management. Okay, because if any management that can reduce the bulk density, it will be a better management, because when bulk density is reduced, the pore space will be increased and the compaction is reduced. Okay, so anyway, without even doing, by seeing the bulk density values, you can tell B is a better management. Okay, so that is so if you want, you can take down this, or you can do by yourself, please. Okay, or you can take a photograph or whatever. Okay, now I am going to give another calculation. Please quickly take down and do and tell me now. Quickly, please. And you can put in the chat box, you can put your answers. I'll give you 5 minutes. Okay, so many of you have already done, and since maybe it is difficult for you to share your work, I'll just discuss. Okay, so bulk density is ms over vt, dry weight over volume. So the volume is given, and the volume of the soil is 640 centimeter cube, and the dry weight, since the wet weight is 1000 and dry weight is 800, so dry weight is 800 divided by volume 640. So the answer is 1.25 gram per centimeter cube. Now, to find the porosity, you all know 1 minus bulk density over particle density. So bulk density you have already calculated, particle density is given. So if you do that, that will be 0.528 or 52.8%. And alternatively, you can calculate porosity using this equation also. Porosity is volume of pores divided by total volume. So in that case, pores volume is total volume minus volume of solids. So total volume is given 640. To calculate the volume of solids, you can use particle density. So using particle density, ms over vs. So if you use that equation, that is 302 is the volume of solids. Okay, so 640 minus 302, that will give and divided by total volume 640, that will give the same answer. Okay, now similar to porosity, for void ratio, the equation is particle density over bulk density minus 1. So if you do that calculation, you will get 1.12. Okay, so that is the problem, and so if you do that, you can please practice. So those who did not do, please practice these kind of calculations. You may get in quiz exams or mid exam or in the final exam, these kind of questions. So please be prepared for that. Today we are going to go for the other soil property, that is soil texture. So what is soil texture? So it is the expression of relative amount of sand, silt and clay in a soil. Okay. So it is the expression of relative amount of sand, silt and clay. Or you take a soil sample and you have to separate how much of sand in that, how much of silt in that and how much of clay in that. Then you will be able to tell what is the texture. Okay, so we'll see how to you will be doing this in your practical class, but today I'll discuss how you will be doing that. Okay, maybe the principle, only the principle I'll be telling. So what is the importance of soil texture? Why we should learn as agriculture students? Why you should learn about soil texture and what's the importance for the agriculture. Okay, so it is a constant property. That is the first thing, because all other properties you can change. Most of the properties you can change. For example, bulk density you can change by adding organic matter, or by doing some tillage you can change. Okay, even particle density to some extent you can change. If you add a lot of organic matter, then you can even reduce the particle density. But soil texture, you cannot change unless you put a lot of clay or sand to the particular soil. You cannot change it. So naturally, you cannot change the texture of the soil or the proportion of sand, silt, clay. You cannot change. So it is a very constant property. So that you should know if you asked which is the most constant property of a soil. Relatively soil texture, even to some extent particle density also a relatively constant property. Okay. So the other thing is this texture will influence other properties such as physical property, chemical property, and even cultivation aspects. Some of the cultivation aspects are also significantly influenced by the type of texture of a soil. So therefore, we should know what is the texture of the soil, and accordingly, we should do the management practices. So for that, we should know how to what is our texture of our soil and how to manage those kind of soils. So that is the importance. And now we'll see what are the physical properties or chemical properties or other aspects that depend that affected by that are affected by texture and how they are affected. So as I have already told you, please have a notebook and write whatever more points I am telling beyond these slides. Okay, because I am not writing everything in these slides, but I am discussing. So if you do not take down anything, then when you are studying for your examinations, you will miss some points. Okay. So now let us see what are the physical properties that are affected by soil texture. Okay. First and foremost important properties of a soil for cultivation is water holding capacity. So if a soil has a good water holding capacity, that will be a good quality. So maybe even if we apply irrigation water, if a soil does not have a good water holding capacity, that is, if it is poor water holding capacity, all the water we apply will quickly leach out, and we have to irrigate frequently. So irrigation involve electricity, and so that will cost a lot. So, but if the water holding capacity is naturally good, then it will be a better soil. So, what about if you compare clay soil and sandy soil, which will have a higher water holding capacity?
Clay type soil.
Yeah, clay soil will have a higher water holding capacity. So you can write down that also. So because we are discussing about texture, so compared to sandy soils, clay soils have higher water holding capacity. Now the next property is plasticity. So we'll study in detail about this plasticity later. So you know what is plasticity. So that is you can if you add some water, and you can make some mold out of the soil. Okay, so you know what is plastic property. It can you can for example with clay you can make some shapes. Okay, so that kind of property is plasticity. So again, clay soils are more plastic than sandy soil, but for cultivation, maybe that property is not very good. Anyway, clay soils have more plastic. Okay, and the other one is hydraulic conductivity. So water holding capacity and hydraulic conductivity are different. So hydraulic conductivity, can anyone tell what is hydraulic conductivity?
The water movement in the soil.
Yeah. So hydraulic means related to water. Conductivity means how easily it can allow water through the soil. Okay. So obviously, sandy soils can allow water better than clay soil. Okay, so sandy soils have high hydraulic conductivity than clay soil. Okay. Next, root penetration. So, for the plants to grow in the soil, their roots should be easily penetrate into the soil. So, normally, uh, clay soils will not allow roots to penetrate easily, whereas sandy soil have easy root penetration. Then, next one is reaction to tillage implement. So, for different soils, clay soil and sandy soil, maybe for clay soils, it is easy to do tillage practices, whereas sandy soil, they will, especially when they are dry, it is very difficult to do tillage. Okay, so reaction to tillage implements, sandy soil is easy to till, whereas the clay soils will be difficult to till. Then specific surface area. So specific surface area means surface area per unit weight. So that surface area is high for clay soils. Do you agree that surface area is high for clay soil, or will it be high for sandy soils? Surface area. Hmm?
High in sandy soil.
Sand.
Sandy soil, high surface area. Mm-hmm. Yeah, actually, the thing is surface area per unit weight. Okay, so actually for clay soil, surface area is higher than sandy soil, because when the particle size is less, okay, they will have more surface area compared to big size particles. Because, for example, if you imagine 1 centimeter cube of a cube made up of 1 centimeter in all dimension, and if you cut that into 0.5 centimeter of 4, okay, when you cut that 0.5 centimeter, there will be some more surface area. If you if you calculate the surface area of those 4 cubes, that will be higher than this 1 cube. Okay, you can do it as a homework and see. Okay, so lower the particle size, more will be the surface area. Then leaching of soil. Which soil will have more leaching?
Sandy.
Yeah, what is leaching? What is leaching?
Water will be drained quickly.
Yeah, so leaching is a downward movement of water through the profile. Okay, so sandy soils will have more leaching than clay soils. Okay, so these are the physical properties. So we may be in terms of physical properties for agriculture, maybe clay soil seems to be better uh, in some cases. But in leaching, because leaching, if you add water, if it immediately leach, that means it will, when it is leaching, it will also remove the nutrients from the soil. So that is also not a good property. But on the other hand, if all the water is stagnated, then aeration will be a problem. Okay, so the balance of these two is important. So if there's a good proportion of sand, silt, and clay, all in a good proportion or a same proportion, then that will be a better texture. So we'll discuss further in the coming slides about that. Now we'll see the chemical properties affected by texture. So one chemical property is cation exchange capacity. So what is cation exchange capacity? So you will be studying in the coming classes in the chemical properties. Anyway, I'll brief what is cation exchange capacity. So you know what is cation and what is anion. Cation is positively charged ions, anion is negatively charged ions. So calcium, sodium, ammonium, all are cations. So most of the nutrients are cations. Okay. So most of the soil particles, soil colloids or soil particles are negatively charged. That you will study later. So because of that, these soil particles can attract the cations and they can hold the cations on the surface of the soil particles. Okay. So if the surface area is high, those particles can have more negative charges and they can hold more cations. So that capacity to hold cations is known as cation exchange capacity. So these cations held on the surface can be exchanged by other cations. So, for example, in a soil particle, there are some cations. Now you are applying a ammonium fertilizer. So in that case, this ammonium has in the soil solution, ammonia is in high concentration. So what it will do is it will exchange the cations on the surface of the soil and to ammonia. So because of that, this ammonium which is exchanged on the surface will not leach from the soil. So that is a good property because nutrients can be retained in the soil. So this cation exchange capacity is a good property. And clay soils, as we have already discussed, clay soils have low surface area and they will have more negative charge than sandy soils and they will have more cation exchange capacity than sandy soils. And the other chemical property is buffer capacity. So you all know what is buffer capacity. So resistance offered by a system to change in pH. That is, if you add some acid or base, the pH of the system will not change much. If that is there, we tell that system is buffered. So normally soil also can do buffering to some extent. And in that case also, clay soils have high buffer capacity than sandy soil. So as I have already discussed, clay has more negative charges. So if you add some hydrogen ions, what will happen is hydrogen ions will be absorbed on the soil colloids and therefore when it is absorbed in the solution, hydrogen ion concentration will not change. So because of that, it can buffer, but pH will not change. There are other buffering systems also, but so for the time being, I am discussing only about this negative charge buffering system. And the other one is nutrient retention capacity. So one is cation exchange, the other one is nutrient retention. So that is this nutrient retention capacity is more related to cation exchange capacity. So if a soil has high cation exchange capacity, it can retain the nutrients what we apply. Otherwise, whatever fertilizer we apply, maybe with irrigation water or rainfall, that fertilizers may be leached from the soil. But if soil has high nutrient retention capacity, those nutrients can be held in the soil and they can be utilized by the plants. Then leaching of nutrients. So if the retention is high, leaching will be less, and if the retention is less, leaching will be high. So leaching is high in sandy soil compared to clay soil. And there are some cultivation aspects which affected by soil texture. So these, for example, type of implements. So in clay type of soil or in sandy type of soil, we have to use different type of implements. We have to for the tillage or whatever, different implements have to be used. So we should know what is the texture of the soil. Then only we can apply implements. Then time of tillage. So, for example, if it is a sandy soil, maybe even immediately after a rainfall, you can do tillage in those soils. Whereas if it is a clay soil, maybe immediately after a rainfall, it will be very sticky and it will be very difficult to work. So, time of tillage also will depend on the texture. Then method and frequency of fertilizer application. So what is the method of fertilizer application and what is the frequency? So for example, split application or basal application. So maybe if it is a clay soils, you can apply all the fertilizers as one dose or maybe two doses because in clay soil nutrient retention is high, so no need to split the application further. But if it is a sandy soil, if you apply all the fertilizers as one dose, most of the nutrients will be lost with irrigation water or rainfall. So normally for sandy soil, you have to apply into 4 or 5 split doses to increase the nutrient use efficiency. So that is method and frequency of fertilizer application. Also irrigation method and irrigation interval also depend on the soil texture. So for example, surface irrigation or overhead irrigation. So surface irrigation is the most practiced irrigation in our country. We apply water on the surface, maybe we prepare basins and in the canal water is applied. So that is surface application. But for sandy soils, this surface application, there will be a lot of losses of water on the way itself. Okay, so to avoid in sandy soils, normally overhead applications are recommended. So, for example, sprinkler irrigation. So, in sprinkler irrigation, you apply less water and there will be less amount of water losses. Otherwise, if you apply in this as surface, most of the water will be lost as leaching. Okay, so even irrigation method and irrigation interval. So maybe in sandy soil you can apply with the higher irrigation interval. Maybe today you apply water, maybe after 2 or 3 days you can apply water for clay soil. Whereas for sandy soil, maybe the interval should be reduced because sandy soil will lose most of the water. So you have to apply more frequently for the sandy soil. Okay. So therefore, since all these properties are affected by texture, we should know about texture. So whether clay soil or sandy soil is better for cultivation. If you ask the question whether clay soil or sandy soil is better for cultivation, what will be your answer?
Clay soil.
Clay soil. So can you cultivate in clay soil all the crops? But what is the crop normally cultivated in clay type of soil?
Paddy.
Paddy. Yeah. So for paddy, maybe aeration is not a problem. Paddy has some tissues where air can be conducted from the shoot to the root. Okay, air-enchyma tissue is there, so paddy can thrive. But if you grow other, for example, onion, can you cultivate in clay soils or any potato? Can you cultivate? Okay. Yeah, so there should be a balance of both. Okay, maybe in terms of chemical properties, maybe clay is better. But in terms of physical properties, aeration and water, air circulation, sand is better. So combination of both is a better soil, which is known as loamy soil. Okay, so we'll continue in the next class. We have 2-3 minutes. I have a quiz for you. Quickly do it, and you can go to the other class. So please, you can do the questions quickly, and you can join the other class. You can go to the other lecture. Quickly do. Can you see the questions?
Yes, madam.
Okay. It will take only 3 or 4 minutes. Quickly do it and you can go. So I'll discuss these questions in the next class. You can do and go.
Recording in progress. Those who finish can leave the class, and you can join the other class.
Thank you, ma'am.
Thank you, ma'am.
Thank you, ma'am.
you, ma'am.